So again, you've dealt with conditionals your whole life. If-then statements. All right? If-then statement is called a conditional. If the light switch is up, then the light is on. Is that always true? No. You probably have multiple light switches in your house that are sometimes they're up and the light's on, sometimes they're down and the light's on. Okay? But in this room, that's a true statement. Okay, if the light switch is up, I shouldn't even say that. We could have a power outage, right? But assuming we don't have a power outage or all the light bulbs burn out at the same time, if the switch is up, then the light is on. The hypothesis is always the if part. The hypothesis is the if part. Okay? The conclusion is the then part of the conditional. Sometimes then is not there. It's implied. I mean, let's face it. You make your mom mad. She looks at you and says, "Go to your room." She doesn't have to say the word "you," does she? You know who she's talking to. So the "you" sometimes is implied, just like this. The "then" sometimes is implied. All right. So let me pause that. I've highlighted the light switch is up, because that's the hypothesis. I highlighted that in yellow. The if part is the hypothesis. You notice I did not underline the word if. Okay? Just like when you did slope. Remember when you do slope and you say y equals mx plus b? Do you remember that? The x tells us where the slope is at, doesn't it? But the x is not part of the slope. The slope is the number in front of the x in that model. Okay? Here, the light switch is up is the hypothesis. It's not if the light switch is up. So when they ask you to identify the hypothesis, don't say the word if as part of the hypothesis. It tells us where to find it, but it's not part of it. Okay? The hypothesis is the light switch is up. The conclusion is the light is on. Okay? Sorry, I didn't realize someone must have saved this after I wrote on it last time. Here I have another one. If 2x minus 3 equals 5, then x is equal to 4. Let's do this so that we all stay together. I'm going to let you think about that for a second while we pause, and then we'll talk about what is the hypothesis and what's the conclusion. Let me say it again. So what is the hypothesis? Jackson? 2x minus 3 is equal to 5. That's the hypothesis. That's what we had written there. 2x minus 3 equals 5. The conclusion then, someone else? Jared? X equals 4. Good. You didn't tell me if or then, because they're not the hypothesis, the conclusion. They are just where we find them. Okay? It's easier when it's math like this, because it makes more sense. When it's a statement like this next one, it says if two lines are parallel, then the lines are coplanar. Sometimes that makes them a little more difficult. If two lines are parallel, then the lines are coplanar. Let me pause while you copy that, and we'll talk about what's what. So in this one here, what is our hypothesis?
Two lines are parallel.
Two lines are parallel. And what's our conclusion? The lines are coplanar. Okay? Good. Very straightforward. When they give it to us, if, then, it's very straightforward as to how to find it. Unfortunately, they don't always give it to us that way. Our RC will win if Andre scores 3 touchdowns Friday. Okay? RC will win if Andre scores 3 touchdowns on Friday. Go ahead and copy that down for a second. So what's our hypothesis here? Someone other than Jackson. Oh, Amber, what do you have?
Andre scores 3 touchdowns on Friday.
Andre scores 3 touchdowns Friday. Okay, does anybody agree with her? Anybody disagree with her? What do you think? RC will win. Okay? I wrote it this way because they will write them this way sometimes, and so I wanted you to see them ahead of time. But remember that if is our key word to find hypothesis, right? So if we rewrote this in if-then form, it would say, if what? Andre scores 3 touchdowns, then RC will win. Right? So the if part is Andre scores 3 touchdowns. So the hypothesis is, oops, sorry. Andre scores 3, I'm going to abbreviate, 3 TDs Friday. Okay? The conclusion will be RC will win. Alright? So if they switch it around on you, you don't have to rewrite it. I'm going to leave that up to you. But you have to at least rewrite it in your head in if-then form. If what? Well, if Andre scores, then we will win. Right? So the if part is always our hypothesis. Any questions on this before we move on? All right? Truth value. For a statement to be true, it must be true for all situations. Always true. For it to be false, it only takes one example that's not true. Okay? So if we go back to, if the light switch is up, then the light is on, is that a true statement? No. How many of you have a situation in your house where the light switch can be down, the light's still on? Okay? Probably most all of us. Usually you'll see them in hallways, won't you? Where you have 2 different lights or a stairwell. Okay? Sometimes just a big room where you have multiple entrances into it. Alright? And so anyway, all those scenarios, they'll use 2-way and 3-way switches, which means that they just interrupt the current. It doesn't necessarily have to be up or down. It's wherever it happens to be left, and then the next one's turned on, and it switches it around. And so anyway, that's not always true. And so that means that that statement I wrote to begin with there was a false statement. It's not always true, then it's not true. Okay? If I said, if the grass is wet, then it's raining.
No.
Is that a true statement? If the grass is wet, then it's raining. I look outside, the grass is wet, it's raining, that seems to be true. But right now I look outside, the grass is wet, is it raining? No. Could be a sprinkler, could be dew, could be the fact it just quit raining. Okay? Could be someone just threw water out on the grass or something. It could be all kinds of examples. It has to be true for every single scenario if it's a true statement. If you can find one, it's called counterexample. You can find one counterexample. That's an example that proves a conditional is false. Counterexample. It only takes one. Alright? It only takes one. It's hard to prove it's true always, but it's easy to prove it's not true. You just find one scenario. Okay? One scenario. Any questions on this? Alright, moving on. Converse. Converse. You switch the hypothesis and the conclusion. To find the converse, you switch the hypothesis and the conclusion. I don't need to record that here. We have an example here. If x is less than 7, then x is less than 9. Is that a true statement? Pick a number less than 7. 2. Is it less than 9? Pick another number less than 7. 6. Is it less than 9? Yeah. Is it ever possible to pick a number that's less than 7 and have it not be less than 9? No, it's not possible. Okay? So that's a true statement. The converse of that now says, if x is less than 9, then x is less than 7. Well, I could pick all kinds of numbers. I could pick infinitely number of numbers that make that statement look true. But I only need one number that makes it bad. So pick a number that's less than 9. 8. Is that less than 7? No. Okay? 7 itself. Is 7 less than 9? Yeah. Is it less than 7? No. So the converse, which says I took this hypothesis and this conclusion and I switched them around, okay? The converse, I take the hypothesis and the conclusion, switch them around, that gives me a different statement, and that's called the converse. And in this case, the converse is not true. Just because a conditional is true, it does not mean the converse is true. Okay? Just because a conditional is true does not mean the converse is true. You're going to be tested on that. Over and over and over again. You're going to be tested on trying to say the converse is true just because the original conditional was true. And you have to understand right now, it is not true just because the conditional was true. Okay? Understand that. We're not going to have time today to do any work on our assignment, but that's okay. We'll get it started tomorrow, and maybe at the end of class tomorrow, then I'll go through notes for the next day. I kind of like doing notes one day and giving you some time in class the next day to work. So I don't mind being a little bit behind that way. At some point, we'll get caught up. It'll be more traditional. But for now, don't worry about it. Any questions on how to write the converse? Okay? The Venn diagrams. We took that statement, if x is less than 7, then x is less than 9. And we put it in a Venn diagram. I'll let you copy this down and we'll talk about what it means. Okay, it looks like everybody's about done with this. So let's talk about this for a second. We said if x is less than 7, then x is less than 9. And I took that statement and I put it in a Venn diagram. What kind of numbers are less than 7? 6, 5, -2, 1.3, 7, 6. All those kinds of numbers. What's that?
6 and lower.
Yeah, actually 7.9999999999999. Get the point?
Yeah.
Did I say 7 point? I meant 6 point. And lower. Okay? Everything just below 7. What kind of numbers are out here that are not already inside this one? 8, 7, 8.9, 7.5. Okay? All those numbers are in there, right? All those numbers. And so, what we're saying is, if it's in this group here, then it has to be in this bigger group. Okay? So in general, what we're saying is the if part of a statement has to go inside the smaller circle. The then part of the statement goes in the outer circle. So when they ask you to take a statement and write it as a Venn diagram, then just remember the if part has to go in the smaller circle, the then part goes into the larger circle. Okay? This symbol here means conditional. It means if P, then Q. Also, sometimes we see it read P implies Q. P implies Q. That means if the P part's happening, we're implying the Q part has to happen. You got your homework done? And what's happening? Mom's taking you to the movies, right? Is that what we said earlier? If you get your homework done, Mom will take you to the movies. So if you get homework done tonight, Mom will take you to the movies.
Think so?
Any questions on this? All right, moving on. They're going to give you some statements that are not in the form of an if-then, not as a conditional, Kayla. And so we need to learn to write these statements as conditionals. So this statement says all giraffes have long necks. I'm going to pause and let you think about this for a second. And I want you then to write this as a conditional. If, then. If something, then something. Sometimes you are asked to write conditionals from statements that are not in a conditional form. So the statement says all giraffes have long necks. We want to write that as a conditional. If something, then something. The key to this is to determine what has to be true. If we said if an animal has a long neck, then it's a giraffe, that's different than saying if an animal is a giraffe, then it has a long neck. In this case, the key here is we're talking about giraffes. And then what has to be true because it's a giraffe? It has to have a long neck. So the proper way of writing this as a conditional would be to say if an animal is a giraffe, then it has a long neck. If we want to write that as a Venn diagram, then we would draw our two circles and then we'd have to identify what has to be true. What's the if part? The if part goes in the inner circle. If it's a giraffe, then what? Well, then it has a long neck. So our Venn diagram has the giraffe on the inner circle and the long neck on the outer circle. Here's a copy of another Venn diagram. We'd like you to take a minute and try to write the conditional that represents the following Venn diagram. So, obviously we'll have to add some words to this so that it makes sense. The key is the if part is the inner circle and the then part is the outer circle. So we're saying if dog, then tails. So if we add words to that so that it makes a little more sense, we might say if an animal is a dog, then it has a tail. Now we could argue whether that's a true or false statement. And some would say it's false, some would say it's true. I would suggest that maybe we could throw in the words born with a tail. I believe dogs are born with tails and sometimes they're snipped or banded so that they fall off. In this case, it really doesn't matter whether it's true or not. They just asked you to write it as a conditional. If, then. if an animal is a dog, then it has a tail. Troy's mom says, if you do your homework, then you can go to the movies. You see Troy at the movies, so what do you conclude? The common mistake here is we conclude that he did his homework. But Mom didn't tell us that if he was at the movies, he would have his homework done. She said if he does his homework, then he can go to the movies. We don't have evidence of the homework being done, so we cannot make that conclusion. The converse of this statement would say if you go to the movies, then you did your homework. Remember, we said the converse is not always true just because the original statement was true. Even though Troy's mom, may never lie, this statement cannot make us conclude that he did his homework, because that would be the converse, and the converse may or may not be true. It is a confusing concept, but one you'll be asked about a lot. Okay? So in this case, we do not have any conclusion can be made. And so Troy is at the movie, then he did his homework. That's the converse, and that is a wrong statement. Okay? We cannot conclude the converse is true just because the original statement was true. Troy may have snuck out of the house. Mom may have never intended on him making sure his homework was done. She simply said, as an incentive, if you get it done, then you can go. So lots of examples as to why he might have been at the movies and still not had his homework done. Okay? Now tomorrow I'll give you time in class, so if you're at home viewing this, you do not have to get this done tonight. In order for us to make a conclusion, the hypothesis must be true. If we do not know the hypothesis is true, then no conclusion can be made. So tomorrow we'll work on 3 through 48 multiples of 3.